Cool. Oh, well, thank you very much for everyone for coming and joining us. We've obviously done, this is our third presentation we've done so far, and we've had pretty good feedback, I think, from all of them. So, and a lot of people quite enjoyed going over some of the photos and sort of annotating what was happening. So I'll try to do that a bit today. I've got a bit of a presentation with, hopefully lots of photos. Some of them are myself, some I've got from Dad, and then other ones I've just plucked off the internet. So hopefully it sort of adds to it all. So I'll get started. I'll share my screen. So hopefully you can all see that. Just make sure I got it sorted. So this presentation will be about basically cross-country flying. I'm going to aim it at people who have sort of gone solo and are looking to taking the next step to going cross-country flying. But it's also a bit of a refresher for anyone who's already a cross-country pilot. And maybe there'll be a few photos and stuff there'll be a bit of discussion about. As we did the other day, if you've got any questions, if they're sort of burning questions, speak up. Otherwise, just write it in the chat. There's a button down the bottom. You can put any questions you want in. And at the end. And if there's anything complicated, I'm going to get Nick Oakley to help me with some of the questions. You might have some questions for him about sort of how to fly fast. So, but anyway, I really enjoy cross-country flying. I think it's what gliding's really about. And all the recent studies GNZ have done have shown that most of the people who stick around in gliding do so because they've got to that cross-country flying level. We get a lot of people dropping out after going solo and they can't transition into the cross-country stage. So getting to that stage is really important. And obviously this photo here is myself and Nick flying around in France, or we're actually in Switzerland, I think, and that's the Matterhorn. So if you stick to gliding, sort of enjoy the cross-country flying, you can actually go some pretty cool places. And this was sort of one of the highlights for me. So just a little bit about what I'll talk about today. So we'll talk a bit about preparation. I don't want to talk about that too much. Then we'll talk about what I consider is pretty important for gliding is what we call cones of safety. So working out how far you can glide and making sure you've always got somewhere safe to land. I'll do a few little diagrams on some maps to show you. I'll talk briefly about landing out, but again, I don't want to speak to that too much. I think that's more something you actually have to go out and practice and do at your local airfield. And then we'll talk through some thermal flying, some ridge flying, wave and convergence flying. And again, we can annotate some photos. And then finally, I'll just finish up with a bit about speed to fly, and then we'll get into some questions. Mainly, I'm going to focus on places I've flown. So a lot of the talking is going to be probably about Springfield, but it should relate to other gliding clubs around the country. So a bit about preparation. If you joined us for any of our other talks, you notice that all the really good pilots spend more time preparing for the flight than they actually do flying it. Flying the task or the long flight seems to be the easy bit. Just the amount of time you see these guys putting into getting prepared is huge. So for me, if I'm going to a new place and I want to fly sort of cross country, the first thing I look at is sort of where are the landouts, particularly in the mountains. That's a really important point, knowing where are the safe places to land at. And there's some really great tools for that. Google Earth, it's fantastic for looking at satellite images of places, and you can also go into 3D mode and look at them. So you get a bit of a bird's eye view of the land out options. Other gliding clubs there might be a land out book, or for instance, on the Canterbury Gliding Club website, we have our sort of page that has all the different land outs on it. And so the picture up there on the top right is taken from our website, and this is a place called Castle Hill, and there's a sort of series of paddocks out there that are good for landing, and so you can sort of use resources like that. The second thing I'd look at is airspace maps. So you obviously want the latest airspace map. You can always use the airspace files on your electronic devices, but nothing beats actually having a map and sitting down looking at a map. So I recommend you get the latest map if you can. Obviously, before you do any flying, you want to make sure your glider's prepared. If you're flying a club glider, make sure you're comfortable with it. Same goes for your own glider. Make sure you're really comfortable in it. And before you go flying, make sure you've got enough warm clothes, particularly if you're going to be flying high. It gets really cold. But also, more importantly, if you land out, you need to have enough warm clothes to last you until someone picks you up. In the mountains, it might take a couple of hours, or you might even have to spend the whole night out there. So just make sure you've got everything prepared. And just a few other things, make sure you've got some tie downs in the gliders, especially if you're flying in wave conditions. You might have to land out in windy conditions, and you need to tie the glider down so you can walk somewhere. Obviously, make sure you got your toilet sort of options. I won't go into too much details. I think you can watch one of Tim's videos on how to sort that. But make sure you've got everything sorted before you go. Obviously, you want to have a crew, someone who can come pick you up. And then make sure you've got some way of being tracked, whether you use Spot or one of Tim's trackers. It doesn't really matter, but as long as you know how to use it and it's reliable, and then make sure you have good communication, so good radio or cell phone, or a charged cell phone with you. So moving on to what I call cones of safety. Other people might have other words for this, but this is basically a way to fly from land out point to land out point and keep yourself safe. So you've always got somewhere safe to land. And this is a really good way to get confident when you're first going flying or cross-country flying, to make sure you have somewhere that's safe to land. And ideally, if you can go to a field before you fly there, you'll have a lot more confidence to go cross-country flying. So what I'm going to do, talk about cones of safety. So just a few rules of thumb. I'm going to use a glide angle of 1 to 33 for our glider. And that's a pretty good conservative value to stick to. The reason I've chosen that, and it's a fairly simple reason, it means that for every 1,000 feet of height I have, I can glide 10 kilometers. So it makes the maths really easy. So we want to make sure that we can always glide to a safe airfield or a safe place to land. So for instance, if we have an airfield that's down here, I'm just going to call it AF for airfield, we want to make sure we can glide there. So if we're 10 kilometers away from our airfield at 1,000 feet, we'll glide there and we'll arrive there at 0 feet. That might sound all right, but it's not really. We really want to arrive at our place to land about 2,000 feet above the ground. And that will give us enough time to look around, make sure we're happy with our land out option. And ideally, it'll give us a bit of time to try to find some lift so we don't actually have to land there. So if we're using that, so if we draw our line up here, so we need to add 2,000 feet on that. So if we leave here at 3,000 feet, we'll arrive here at 2,000 feet, which gives us plenty of height to sort of plan our landing. So what I'm going to do, I'm going to draw some diagrams on a map, which will hopefully explain it a bit better. So I'll just get up CU. So I'm going to use Springfield as my example because I know it. So obviously we're in the South Island of New Zealand. Christchurch is down here. I'll zoom into Springfield. So I'm going to use our nice easy numbers. So I'm going to use 10K. So if I get the ruler out and just take a brief note where 10K is. So if you look at the bottom left of the screen, you'll see the it's about 10K there. Out this way is 10K. So I'm going to draw on this. Ignore that line there. So I'm just going to draw roughly 10 kilometer circle around Springfield. And this is assuming no wind. So Springfield is just here, and Springfield's at 1,200 feet above the ground. So if we want to arrive at Springfield at 1,200 feet, we would have to be at 10 kilometers at 2,200 feet, which again is not really good enough. We need to be higher than that. So I'll just draw a little diagram out here. So if we want to arrive at Springfield at, so Springfield's at 1,200 feet, and we want to arrive there, or if we're at 2,200 feet there, we'll arrive at 0 feet. Again, not really good enough. So we want to be arriving at 2,000 feet above the ground. 2K. So we need to be 2,000 feet higher than that, so 4,200 feet. Excuse my terrible handwriting. But so anywhere around the outside of the circle, if we're at 4,200 feet, assuming that there's no wind, we'll arrive safely with 2,000 feet to play with over Springfield. So bear in mind that this drawing circle assumes there's no wind. If we've got, say, a southerly wind from this way, our circle is going to look a lot different. We're not going to, if we're at 1,200, or yeah, 1,000 feet above the field, our glide circle is going to look something like this. You're not going to be able to glide as far into wind, and you're going to be able to glide a lot further downwind. So it's just a brief summary about that. But for all my calculations, I'm going to assume that there's no wind. And later on, if anyone wants any formulas for how to work out your glide angle with wind, I'll send that through in the notes. So we know our glide circle from Springfield, and we said it was 4,200. Anywhere in that circle, if we're above 4,200, we'll make it back to Springfield safely. So if we want to then move on to another airfield, so there's another airfield out here, not far away from Springfield. That's quite a good one. So if we want to join these two cones up, we then need to work out our cone of safety for this. So let's get rid of that. So we have to know the ground level. So if you look at the bottom left of the screen, you'll see the height in feet. So this airfield here is, I'm just going to call it 1,800 feet above the ground. So at a 10K radius from this field here, 10K radius from the field, if we are 2,800, we'll arrive there at 0 feet. Again, not really what we want. We'll arrive there at least 2,000 feet above there. So 4,800. So you can sort of see how these two circles are starting to combine here. So if we're in this circle here, the one around Springfield at 4,200 feet or above, we can easily make it to Springfield. If we're in this circle here at the one around our airfield at 4,800 feet above, we can easily make it to that airfield. So you can sort of see how they start to combine, and you can use that to then fly safely from one airfield to another. So if I zoom out, I'll just do one more quickly for summary. So that's sort of moving to the west of Springfield. When we want to get into the mountains, we might want to get to Castle Hill, and that was in one of those first photos I had of the Castle Hill airfield. If we want to use our cone of safety, so I'm just going to guess where 10K is. I think it's roughly there. And I know that Castle Hill is 2,400 feet above the ground, so 2,400 feet above the ground. And again, if we want to get into that 10K radius, if we leave at 3,400 feet, we'd arrive there at ground level, assuming no wind. So we need to be another 2,000 feet above that, so 5,400. And you can sort of see, so if I just draw that circle we had around the airfield and the other one we had around Springfield. Obviously, if you're going to draw these on a map, you'd want to use a compass to make it a bit easier for yourself. But you can start to see how you can move from Springfield to the other airfield and then to Castle Hill. And you can do that all safely with staying in glide range of these fields. And if you can go walk on these fields and actually be there on the ground, you get a really good confidence to go across country flying, and you can sort of feel safe as long as you're above those heights on the cone, and you can draw it on a map, you'll feel pretty safe and you can gives you the confidence to start flying cross country. So I think that's enough about cones of safety. Hopefully it makes sense. If anyone's got any questions, write a note and perhaps we can, I'm happy to go over it with other people after if they like. I'll just jump back to my PowerPoint.
Alex, there were a couple of comments in the chat you could cover.
Oh yeah, so Mike's comments there, 1 to 20. 1 to 20 is a really good glide angle to use for any of your estimations or when you're flying. These rules of thumb are exactly that, they're rules of thumb. Obviously, you can get a lot of sink in the mountains and your LD or glide angles can reduce, but I think using a 1 to 33 just makes everything really simple. And you obviously you can add your own safety margin on top of that. When I fly in the mountains, and I know I want to get to a land out or something, I quite often fly set to make sure I have a glide angle of 1 to 20. It's sort of something that's achievable. But one of my sort of things for homework I was going to get people to do is next time you go flying, actually have a look at what glide angle you can achieve in your glider. Set up a glide computer. You can use your cell phone if you have to. Don't pay too much attention to it. You can look at it when you get back on the ground, but just have a look. Try to do a 10K glide and see what glide angle you can achieve. Obviously, see how your speed affects the wind, and that'll give you a good idea of going forward. So we'll move on from that. So I was going to briefly talk about land outs and sort of get rid of that. So briefly talking about land outs, I don't want to talk about it too much, but like I said, I think getting into land outs is something you should really do with an instructor at your field. Practice your precision flying, practice your precision landings, because that's really what a land out is. And when you've got the chance, go and do some land outs with an instructor. It's not something that you should be afraid of, and it's I've probably landed out more than most people. So it's something that you do, and if you get good at it, it's something that can be quite exciting, and it's a pretty fun day out when your crew comes gets you, and you can make a good day of it. But it is something you really need to practice. One thing I recommend is when you're landing back at your own airfield, make sure every landing is a precision landing. Treat it like a land out. One thing we've been doing recently at Springfield is our midwinter competition. So for this here, we've been setting up a practice fence and a practice field. So you can see we set up these little toys, these little bushes, and it's a great way to practice our precision landing. So you can treat it as a fence and mark out your field, and it's also great fun. So I recommend if you can talk your club into it, set up a midwinter competition and get everyone to practice. What we tend to find is our ab initio pilots actually do the best. Our instructors and more senior pilots are possibly a bit more relaxed and a bit sloppy with their precision flying. So it's a great way to test everyone's ability. But like I said, when you come back to your airfield after a local flight, make sure every landing is precision flying or precision landing, and that will help you when you go to needing to land out. So I'm going to jump in now to thermal flying. When you think of gliding, thermal flying is probably what it really started with and what most people think of it. I've got a few photos we'll try to annotate. But the key thing for me really is that the sun doesn't heat up the air. The sun radiation heats up the ground, and then it's the ground that heats up the air. So you want to really try find areas of the ground that are going to heat up more than the surrounding areas. So in this diagram here, this ploughed field is going to heat up a lot more than that marsh in the middle there, and create pockets of warm air that are then going to rise. So that's probably the start. The next thing, you're obviously going to have, well, if you're lucky, you'll have thermal clouds, cumulus. Sometimes you don't. Sometimes you might just have little tiny clouds, or sometimes it'll be completely blue. If you do, it's quite can be a really good indicator of where the thermal is. There's a bit of a debate about what a thermal actually looks like. Some people just think it's a little bubble rising up. Other people talk about it being a column, as drawn in here. I prefer to think of them as bubbles rising up. Obviously, the thermal's going to be affected by the wind. Depending on how strong the wind, the thermal might come off on an angle like that. So the really tricky bit with trying to find thermals is trying to look at the source, and then where it relates to where the cloud is and where you are in the sky. You've got to try sort of link yourself up with that to try anticipate where the thermal is going to be, and that can be a really challenging part of it. So moving on, I've got another diagram here. You can see the difference between the wind strength in these. So you can see this one here is much more affected by the wind. So for instance, if you're down here and your glider, that's my glider, by the way. If you're down here in the glider, you might look up and see, look, I'm under that cloud. I should be in the lift. But in reality, the thermal source is probably somewhere over here. So you really need to try and bring your glider somewhere in between the thermal source and the cumulus cloud. And that can be easier said than done sometimes. If you're lucky, there might be a ridge or something here, something that gives it away, so you know where the thermal is. The other thing that happens is sometimes it might just be a bubble like this that's coming up, and you're underneath the bubble, so you've sort of missed it, and then there'll be another bubble coming along after. So the real, I guess the important bit is when you're up high, clouds are really important, really useful. You can try and look for, say, the darker parts of the cloud. The darker parts will indicate where the stronger lift is. When you're down in the middle, you sort of want to look, so somewhere in this height or this height here, you want to start looking up at the clouds, but you also want to look down at the ground, trying to find out where your thermal triggers are going to be. And then if you end up stuck down low, you're going to spend most of your time focusing, we should spend most of your time focusing on the thermal triggers, so darker bits on the ground or ridges, rather than spending too much time worrying about the clouds as such, because you're more likely to find something coming off the ground than you are from the cloud. So I sort of hope that makes a bit of sense. So where thermals make a lot more sense is in flatland. So Australia is a great example, or possibly some places in the North Island. When you get really big flat areas, you get nice sort of even homogeneous thermals. So this is a photo I took flying in Narromine, and you can see nice big cumulus, and they're sort of nice and evenly spaced around the sky. You've got a bit of a blue patch here, but for the most part, they're pretty even. So you can imagine just change the color of my pen here. You can imagine the sun rays coming down here, heating up sections of the ground. Which then cause the ground to heat up, and then you get sort of bubbles of air coming up. So, for instance, at this height here, I'm mainly focusing on the clouds. It's fairly obvious which cloud I'm going to, and you can sort of see, doesn't look like as much wind. I'll be going to the darkest spot of this cloud here, trying to find the thermal. One thing I would say is when you're trying to find or when you do find a thermal and you want to work out where to go next, it's a really good idea to try look ahead while you're actually a bit lower. When you get up to cloud base, it can be quite hard to see where the next cloud is or where the best spot to go is. So for instance, if I'm gliding down here and I find a nice thermal just here, it's about that time I'm going to be looking ahead and working out where the next cloud is, because it's easy to see. When I get up to the cloud base, it's quite difficult to see because you're can't really see that far ahead, and you can't get a good look at the clouds. So it's just a bit of advice. When you want to move on to the next cloud, have a look while you're low. It makes it a bit easier. Obviously, when you're flying along in thermal conditions, if you've got a task, so let's say we've got a turn point, a task, we want to go down this way. It's fairly obvious we'd be flying straight along this way and jumping from cloud to cloud. If we had a turn point a bit different, way out in the distance out here, we'd sort of have to decide, do we carry on this way, or do we go through the blue hole and hope we get a blue thermal, or do we try jump from this one little thermal here onto the next one? And that's sort of, I can't really tell you an answer to that. That's part of the fun of it, is trying to work out the fastest way to fly through the sky. The rule of thumb is generally, if you don't want to do any variations more than, say, 30 degrees. So if that's where we want to go to, I'll do a better job of that. If that's our turn point there, that would be the direct track. We're obviously going that way. We don't want that angle there to be any more than 30 degrees. Probably haven't done the best job with that. It'd be more like that way. But that's just a rule of thumb, and it's, like I said, that's where the fun comes into it. It's trying to work out the best way to go about it. Next example is what I was saying. When you're down low, it's quite easy to see where the best clouds are, and what we're looking for in a cloud. Obviously, the clouds go through cycles, but we're looking for the darkest spots of the clouds. That's going to be where the best lift is. When they start to get a little bit scraggly, so for instance, possibly that one there is starting to die. So these clouds go in little cycles. So you might have a nice big bubble of air going up into that one, maybe another bubble of air going up into that one. And this one, the bubble may just be sitting there, it's almost finished. It's going to slowly start to die. So you really want to look for the nice black clouds with a defined bottom. Is going to be the key to finding a good lift. So that's looking at the clouds. So an expert's going to be looking at what triggers the thermals. So I've got this photo here from the Canterbury Plains, and you can just, one of the rules or theories I got from G. Dale, actually, which I find really useful, is when I'm flying, is imagine you're on the ground. If I was standing here, or if I was standing here, where's it going to feel the hottest? And you can imagine if you're in a dark field that's recently been plowed, it's going to feel pretty hot. But if you're standing in, say, a wheat field, a nice green field, it's going to feel a bit cooler. So you can imagine there's going to be a temperature contrast between this field here and this field here. So that's quite likely that you possibly get a thermal, a bubble of hot air forming there, and you just need it to rise up. So if I was trying to find a thermal here, I'd be flying over this field and this other dark field here. And you've got another one in the distance. So I'd be flying along here somewhere, and I think that would probably give me a pretty good chance of finding a thermal. The other spot you could possibly get is down the river here. You got lots of shingle, and that's going to heat up as well. So my sort of advice for you is picture yourself on the ground. Try imagine what the temperature is going to feel like, and that'll give you an idea where you're going to find these thermals. The other good thing is quite often, if you have a row of trees like this, and let's just pretend the wind's coming from this way, in behind these trees in here, it's going to be sheltered and it's going to heat up a lot faster. So again, if you're standing behind this, it's going to feel a lot warmer than if you're out here in the wind. So behind these trees, this is where I'd think it was probably a pretty good place for a thermal. And you might even get the wind coming through and helping to kick it off. So just try and imagine what the air is going to be doing, and it's not going to always work, but try find thermal triggers. The other thing, this is particularly useful in Australia, is let's say this field here is heated up. We've got a warm pocket of air here. If it's quite stable, it might just sit there. It might not actually come off. But if someone drives their tractor or car or anything through it, sometimes that's enough to trigger a thermal. So keep an eye out. And what you might do is you might see some dust blowing this way or something behind the tractor. It might give you a bit of an idea. So just keep an eye out for that. Next bit, obviously, thermals in the mountains are a bit different. Again, if we pretend there's no wind, the sun's going to be heating up the ground directly, but you can imagine the sun's rays in the afternoon are going to hit mountains more directly. So you're going to find these bits of the mountains are going to heat up more than the valley floor, particularly if there's any lakes or rivers down there. So that's going to create, change the color of that. That's going to create rising air up the side of the ranges. So obviously you want to fly on the sunny side of the ranges, and you can see through here we're getting some nice black clouds coming off. So it's pretty obvious that the air's rising up like this. And so the challenge here is trying to link. If you're down low, you obviously want to be down on the ridge in here where the lift's going up. If you're up high, you want to be flying along under the darkest spots. So that's like what I said. You've got to sort of, depending on what height you are, you're either looking at the clouds or you're going to be looking at the thermal triggers. If you're in the middle, you sort of got to try to judge both of them. So obviously, if there's any wind, that's going to change it as well. That'll add to some to ridge lift, or vice versa. If the wind was coming this way, it might get a bit more complicated, where you've got the sink from the wind coming with the lift from the ridge, and that's sort of never really a good combination. So it's just important to try and pay attention to what's going on. And you might, if you're real clever, you might be able to work out what sort of glider this one is, or where I got the photo from. So I'll quickly talk about centering a thermal, and this is a bit similar to what I was talking about with land out. It's something that you have to practice and doing, and there's not too much advice I can really give you on it. I personally think it's something you should just really go and practice and do for yourself. It might take a lot of flying around to do it, but it's something that you can look at as many diagrams as you want, but it's really something you have to go fly and do. But one thing I would talk about is when you're flying along and say, for instance, you feel like there might be a bit of a thermal here. So this is a thermal. Obviously, you feel like there might be a bit of a thermal there, and quite often, for some unknown reason, you seem to turn the wrong way. I do it more often than not. What I would say is keep the turn coming around. You'll suddenly find you're in some sink here. The air's going down, but just keep the turn coming around until you're at 270 degrees to where you left off or where you're flying. Roll out. I reckon means just rule of thumb, 3 seconds. Roll out for 3 seconds, and then roll back in, and that should hopefully give you center you up in the thermal again. And then from there you can do the fine tweaks to center it. The example on the left is what happens if you try recenter or reverse the turn. You can see this person's come around in the sink and they thought, I'll try change direction, but you can see it quite often ends up out of the lift. So if you can do that 270 degree turn, you quite often find that's the fastest way to center the thermal. Next up, I'd say don't let the air push you around. If you want to get somewhere there, fly straight. You can see in this example here, this thermal here is going to push this glider's left wing up, and it's going to push him to the right. And if he carries on doing that, it's going to push him out this way. And then when he hits this thermal, it's going to push his right wing up and going to push him around to the left. And you can see if he carries on doing this, he's going to miss every single thermal in the sky. So you really want to either fly straight point to point. So best option would be to fly in one direction, and you got more chance of actually hitting the thermal. The other is to do exactly opposite of what the air is telling you, or what's the air is trying to force you to do. So for instance, when this glider hits this thermal here, the thermal's going to want to push him to the right, and he's better off to then turn to the left, and suddenly he'll find a bit of lift. So I just say, don't let the air push you around. If you're going to fly somewhere there, fly straight, or do the opposite of what the air wants you to do. that's enough for thermals. Quickly onto ridge flying. We covered this a little bit with one of the other talks. I don't need to draw too much here, it sort of explains itself. You get, when you've got the wind coming up, it'll blow. If you've got a ridge in the way, it should blow up it, and you get this really nice ridge lift that you can fly along. Again, something that is quite good fun to do. What does it look like in real life? So you can see this ridge here, the wind's coming from the left. So this is the Craigieburn range, close to Springfield again. And you can see the two gliders there. You can notice that they're not actually flying straight down the ridge because there's a bit of wind, they're actually crabbing. So he's flying out this way, but it means his track is actually straight down the ridge. And obviously, depending on how strong the wind is, you want to stay a good distance away from the ridge. And you want to make sure you're flying a safe speed. So I'll talk about that a bit later on. But if you need some guidance on safe speed to fly when you're close to the ground, which you are on a ridge, have a look at the cross-country section of the training program. So just a couple of little things about flying on the ridge. Ideally, the wind's going to hit the ridge straight on. So if this is our ridge here, I think this photo's down in Amarama somewhere. If the wind's coming from this way, it's fairly obvious we'll have nice smooth ridge lift here. The trouble is the wind doesn't always hit the ridge straight on. Sometimes we might have the wind coming down the valley like this way, which means you might find that you get ridge lift in these little spurs sort of around the corner here, but you might actually find you're starting to get it blowing down on sort of faces here. So that's what the image on the left is trying to show you. The wind's obviously coming from this way. Where you've got spurs on the ridge that are into wind, you can get quite good lift, and then where it comes over the spurs down the other side, you can get sink. So it's sort of worth trying to pay attention to what direction the wind's coming from. The other thing I'd say, what are some of the other things that can cause some of the ridge not to work? And this photo might be a bit of example. We might be getting some wave where the wind's coming down, up again, and then it's actually coming down again on the ridge. And you can imagine you might end up with the wind actually coming down the ridge, or at best just no action on the ridge. So it's sort of these little signs that you got to pay attention for when you're ridge soaring. And ideally, you want to sort of feel the ridge out before you go too far down it, and make sure you stay sort of safe and keep somewhere that's safe to land, because you can get pretty bad sink sometimes on the ridge. Next slide is from our training program. I'm not going to run through this, but it's just the most important rule of flying in the mountains. Don't hit the mountain. There's 6 points there, which you can read in your own time, but again, they're all very important, and I recommend anyone who's going to fly in the mountains has done a mountain flying course beforehand. So I'll talk next about convergences. So those who listened to our first talk, I spoke about them. So I used this diagram the other day. It's just a very brief diagram about how convergences work. So just real quickly, so say we've got our warm air mass coming in here, and our cold air mass coming from the sea here. We'll get a convergence somewhere in the middle. And what happens is the cool air mass gets sucked up, and because it's more dense, it'll condense first, and we get these little daggy clouds where the two air masses are meeting in the middle here. And that's quite a good indication about if there's going to be a convergence. And ideally, to climb best in the convergence, you want to be on the warm air side of those daggy clouds. And because there's a lot of mixing of air going in here, they're quite often little bubbles of air coming up, and you sort of almost want to take what you can get. So take your little take as much of the lift as you can, but don't be disheartened if suddenly it dies. And it's just these bubbles sort of mixing and mingling. And you might find suddenly you got some really good lift and then it'll die and then it'll come back. Just yet, don't be disheartened. That's sort of fairly standard with convergences. So I've got a few examples. Again, this one's from Springfield, and you can sort of see the edge of the convergence running around this way and then down this way somewhere. So on the on our left, we've got all the daggy clouds, and you can sort of imagine those getting sucked up as the two air masses meet. And up here, we've also got the same daggy clouds. So you always want to stay on the warm air side. So you can see the warm air sort of marked by the higher cloud bases. So if you can stay on this, in this case, the western side of the convergence, you should find the best lift. And again, don't be disheartened if you get, say, for instance, a really good climb just here and it dies. You sort of just take what you can get and then move on. You'll find something more. So this next photo I used the other day as well. This is an example of a really quite fun convergence we had at Springfield last year. And again, you can imagine the warm westerly air coming in here, and the cool air coming in here. And you can see the cool air is in a bit of a wedge. You can see it like this coming in, and you can see all the cold air condensing as it's getting dragged up. This one there, you can see that the air on the west is a bit dry. If it was moisture, you'd probably have another higher cloud base just here, but there's not too much moisture in it, so you sort of have to imagine it. That's what I say, sometimes convergences you can either have no cloud, or you can have the daggly cloud and the sort of the colder cloud, and then you can have the warmer cloud as well. In this case, there's not so much the warm cloud, but you can still sort of imagine the best way to fly down the edge of it. Obviously, they can get a bit more complicated when you've got mountains involved. So again, I think we talked about this the other day, but you can see the cold air coming here, and the warm air coming here from the left. And in this case, we've got the high cloud base on the warm air side. So in this case here, you want to try fly under the darker bits of these clouds, and you'll find the best lift. This convergence is going to be enhanced by the any ridge lift you're getting off this. So you want to stay on the ridge, the upwind side of the ridge, and in the convergence. So you still want to be flying along here, and you can imagine it'll be a pretty strong lift. This next photo is sort of showing how convergences can be a bit more complicated. So at Springfield recently, we had this convergence, or it was almost a cold front come in, but it didn't have much moisture. And so this wedge of cold air came in, and you can sort of, it's quite hard to see, but you can see this air through here is all hazy, and that's the cold air. And this air up here is a lot more cleaner. It's the nice mountain air. And you can see the sort of the angle, the shallow angle of that cold air. So if you wanted to find any lift under this convergence, you'd have to come all the way out to the wedge of the air, and you can imagine the air is going to be triggered off like that. So it's not as simple as flying under the clouds like this. It's a matter of trying to work out what the air is doing, and you can imagine for it to be such a cold wedge like that, it's normally such a contrast in temperature. So that cold air is really cold, and then the mountain air is a bit warm, and that'll create that wedge. So you really want to have a look at any indicators that are going to indicate where the convergence is. You might be lucky enough to have a lake on the ground that shows you what the wind's doing, or you might, like this instance, have really hazy air and you can actually see it. But I just wanted to show sort of how complicated it can be. And for instance, this day in particular, we had quite a few people tow up and sort of release under these clouds here, thinking they were going to get away, when in reality they had to be all the way out here to find the lift. So I'll quickly talk about wave. I know we spoke about it in detail the other day, but I think I just wanted to talk quickly about how you actually get into the wave. We didn't discuss it too much the other day. This is a basic diagram of wave again, and it sort of summarizes it here. You obviously want to try climb up in these rotor climbs, and then punch forward into the nice laminar airflow. In reality, it probably looks more like something like this: climbing up, getting to sink, going into wind again, climbing up again, and then trying it again. One thing I would say with wave flying is be really patient. Just try to get as high as you can before you try punch into the wave, and it'll make things a lot easier. So what does it look like in real life? So we used this photo the other day. You've got your nice edge of the wave there. You really want to try climb up underneath the cloud, under the darker spots of the game, because that's going to show you where the best lift is. And then you're going to want to try punch into the laminar flow. So if you can imagine the laminar flows coming down like this and then coming up here. I'll draw another one up there. So if you can climb up in your thermal underneath, you want to try to get as close to cloud base as you can, and then you're going to punch forward as much as you can until you get into the nice smooth laminar flow. And you'll see these wispy little clouds at the front edge of the wave, and that's a really good indicator of where you need to be. And if you're below the cloud, you need to be a lot further upwind. So sometimes you need to be all the way up here to actually get into the laminar flow of the wave. So that's thermaling into the wave. If you're lucky, you can climb into the wave by a ridge. And at Springfield, we've got quite a few spots where you can do this. The photo on the left is again the Craigieburn range. And you can see this range up ahead here has triggered a wave that's come down up like that. So you can see the wave line there. But you also notice it's at this on top of the ridge. So if you can fly along the ridge down here, climb up and then push into winds, you'll get into the laminar flow. And that's one of the quickest ways you can get into the wave. So there's a few sites around Springfield and around the South Island that are perfect for that. Down in the Marama Saddle and Hugo's Elevator sometimes work the same. The second photo on our right, again, close to Springfield, and you can again imagine the wave coming along like this. So if you can find, it's not always in sync like this, but if you can find a scenario like this where you can climb up on the ridge and the ridge lift, and then you'll transfer nicely into the wave. And again, that's one of the easiest ways you can get into the wave. And yeah, if you're quite lucky if you can do that. I'm not going to talk too much about flying distance in the wave, because we covered that with the talk the other day. I've got this next photo just to demonstrate some of the dangers of flying in the wave, or particularly flying in high winds conditions. So this is close to Springfield and it's looking south, and you can see this through here is the Rakaia River, and you can see all the dust being blown down there. So that's a fairly good indicator that you've got really strong winds. So whenever you see that, you need to be pretty careful. It might be all right to take off from the airfield, but if you're going to have to land out in these strong winds, you've got to be pretty careful. So it's just a word of warning, really. If you're flying in strong winds, make sure you're pretty cautious and think about what you're going to do if you do need to land out. Again, make sure you've got those pickets with you if you're going to be wave flying. So that's sort of enough talking about the types of lift. I'm going to very briefly talk about speeds to fly. And in regards to speed to fly, I've heard a few people sort of say, oh, they don't really worry about how fast they fly. They're happy to sort of fly around the sky fairly slowly, just enjoy themselves. But then they go, oh, I'd love to do say a 500k flight. So for instance, if you're flying around, say you fly around a 100-kilometer task and it takes you 2 hours, you might think, oh, that's not too bad. It's 50 kph. If you then want to try to 300k and you keep that same flying style up, suddenly it's going to take you 6 hours to do that 300k flight. So that's sort of doable. It's a big day in the sky. But if you want to then jump on and try to a 500k flight, you're sort of talking 10 hours in the sky, and it's a very big day. So you really, if you want to fly long distances, you really need to sort of talk about flying faster. So there's a few different methods to fly faster. Obviously, one of the important ones is the McCready theory, which I'll talk about here, but I do want to emphasize that the McCready theory is good for describing what speed you should be flying between, say, thermals, but in reality, the fastest way to fly fast is by finding the best lift in the sky. So if you can use some of those methods I was talking about before and combining your knowledge, you'll be able to fly a lot faster. So the McCready theory basically describes the speed you should fly between thermals. So this diagram here sort of sums it up the best. So this is our glider. And if he, obviously under each of these clouds, we're going to have a bit of lift. And if he flies really fast, let's say 100 knots, for instance, he's going to be the first one to get to the cloud at the end, but he's not going to have enough height climbing it. So he's going to probably end up on the ground. So you could say he's obviously flying too fast. He's taken it to extremes. If we look at, for instance, maybe glider number 2, he's sort of happy to fly a bit slower, take all the climbs. So these climbs here, let's just say they're 2 knots, 2 knot thermals. And then down the end here, we have a nice big 6 knotter. You can see it's a bit bigger. If he just bumbles along a bit slower, he'll still get there, but it's not going to be the most efficient way to fly. Then if we look at these other gliders here, number 3, he flew a bit faster. Again, he took most of these 2 knot climbs, but he's flying a bit faster. He's still going to arrive at this last climb a bit earlier than number 2, and he's probably going to catch up. So he'll end up in front of number 2. And then number 4, he has flown again a bit faster, but he hasn't climbed under these clouds, so he hasn't wasted time. So he arrived a bit lower than the other guys, and he ended up in front. So he's the highest one there. So that's in a nutshell how the McCready theory works. In reality, it just tells you how fast you should fly. So on the sort of, if you're in an old school glider, you'll have a McCready ring on your Vireo, and you set that to the climb you're expecting. And if you put it in there, it'll tell you what speed you should fly. And that's technically the most efficient speed to fly between the thermals. In reality, it changes depending on if you're in lift or sink. And modern day glider computers are great at telling you what speed you should be flying at that point in time. So I emphasize that point that I said at the start, that it's more about trying to find the best lift in the sky, and that'll sort of help you increase your cross-country speed, which will then mean you can fly further and start to look at doing these longer flights. So that's about all I had really. Do we have quite any questions there, Tim?
Just a couple of comments. Back when you're talking about thermals, Trevor mentioned travel into wind or downwind using the cloud as your center. It's very true. If there's any wind at all, you want to line up with the clouds. So
yeah, no, that's a valid point. I wonder if I have a photo that will help with that. But yeah, any other questions while I look for it, Tim?
And Brett mentioned cloud shadows tell a story too, which is very useful when you're, especially in Australia, or any time that if you're too high to see the clouds ahead, being able to see the clouds on the ground, and more importantly where sun is getting through on the ground further up ahead is very useful.
Yeah, no, I think that's a great point there. Like I was talking about, when you're close to cloud base, it's really hard to see in the distance, but like you say, you can see the cloud shadows, and if you're flying into, like you sort of say, into difficult weather where you might get some overdevelopment, if you can see where there's some sun on the ground, that's going to be really useful in trying to find where you might find some lift. Like I said, when you're getting low or things are starting to get difficult, looking for your thermal triggers is really important, and where the sun on the ground is going to be hugely important.
Russell asked, the landouts near Springfield, are they sloped? Do a lot of them have significant slope, or are they all pretty flat airstrips, or what are they like?
Well, it's an interesting question. Yeah, some of them do have slopes. I wouldn't say any in particular have. Well, there are some really sort of wild ones that I guess people would be landing on with their planes sort of only. But the ones in our database are generally pretty flat. They might have a little bit of slope, but that's part of your sort of field selection or your land out processes, going through your, I think, seven S's, and obviously slope is one of those and pretty important. So yeah, I'd say generally most are fairly flat, but it's something you got to be really, really careful of.
Yeah, I think up around Taupo, for example, a lot of the strips are quite sloped, and the trick there is to make sure the bin is at the top.
Yeah, that's
learned the hard way.
Yeah, and I think your instructors, I recommend trying to do some land out training with your instructors. If you can go to even another airstrip and do some takeoff and landings from there, it's going to be hugely advantage, or sort of will sort of help you out understanding what it's like to fly somewhere different with different landmarks. So it's something that this coming season we're going to try to do a bit of that at Springfield. But like I said, if you can practice your precision landings at your airfield, that's great way.
Yeah, we'll come to Matamata. It's gliding paradise with beautiful paddocks everywhere. Tim asks, do you draw cones of safety on your maps when planning for a task or comp flying? Does XC or such provide such features?
That's a great question. So yes, yeah, if I'm getting into cross-country flying, absolutely, I'll draw my cones of safety. If I'm flying somewhere new, I'll draw them on my maps. If you, I can help you with it, Tim, but if you seal your maps up with some sort of book sealant, then you can write on it in Vivid and wash it off. So it's a great way to, and it'll just give you that confidence when you're flying. In regards to XC or using any of your glide computers, absolutely. So you can set it up so it'll tell you what glide angle you need to achieve to reach certain airfields. So like I think Mike was saying earlier, if you can set it up so it'll tell you if you're going to achieve a 1 to 20 glide, that's really useful for finding places to land or making sure you're safely inside that cone and you'll make it there.
Yeah, I find having arrival altitude is sometimes quite handy on all your waypoints. So you can glance at your map and see you'll probably arrive at some airstrips that are ahead at 3,000 feet. You know you're going to be fine to reach there. Whereas if they say 150 feet, it's getting pretty marginal.
Cool, thanks.
Any other questions? Or I think nearly there, are we, Tim?
Yeah. I think one thing I read about recently, which might be of interest, is Safety McCready. Have you used that at all?
Oh, I haven't, no.
So that might be a good thing for people to go and look into. It's kind of a similar way to setting a safety altitude on all your points you want to arrive at. But by setting a Safety McCready, it also takes into account wind and other things that will affect your flying. So have a look at Safety McCready, and it might be worth doing a talk on that separately at some stage.
Yeah, that sounds good. Oh,
Another question here from Alex. How choosy are you with thermals? E.g., do you take what you have or plough on ahead with what you think will be a stronger thermal? Next one's always better. Just keep on going.
yeah, yeah. It all depends, doesn't it? It depends on your height. If I'm flying in a competition, or particularly in Australia, I set what I call my usable height band, and I want to stay within, say, the top half of the lift band. You normally find the lifts stronger in the top sort of half of the altitude you're playing with. And so if I think I can get to the next thermal and stay within that nice lift band, I'll probably plough on ahead. But like I said, I've landed out more than most people, and it's normally for that reason that I've just carried on. And so, look, it just depends on what you see ahead. If you're flying purely just a McCready theory, you shouldn't stop for any thermal less than what you've set your McCready as. But yeah, it doesn't always work, and you've got to look ahead, think about what's going to be happening in the sky. Yeah, if there's going to be any, say, overdevelopment or anything like that coming up, and you want to be high for that. Yeah, so it's not quite as simple as that. One thing I would say that I sort of probably forgot to mention at the start, for me, flying gliders, and in particular flying cross country, is about creating a mental picture of what's happening in the sky, trying to picture where the lift's going to be, what's happening, what's going to be happening with the weather throughout the day, and then sort of as I go flying, I change the model depending on the sort of inputs I have. So if the thermals are quite good, I'll change the way I'm thinking. But if they're all turbulent and I can't find the lift, it'll sort of change what's going on in my head. And so you're always sort of changing the model you've got. I find quite useful.
Here's a question for the audience. Who here flies around without changing the McCready on their PDA or flight computer and just leave their McCready at 0, which is what I did for many years? Quite a few. It's probably one of the worst things you can do when you want to make sure you can get to places. So if you're thinking about, are you going to reach airfields or not based on your PDA, if your McCready's set to 0, it will tell you whether you'll get there or not based on whether or not you're doing a perfect glide or not. And so you always want to set your McCready a bit higher, at least 2 or 3, to make sure that it'll give you a reasonable estimate of getting to waypoints. So it's just something to look into for anyone else.
I see we have another question there. Are there any significant differences between Omarama and Springfield? I'd say yes and no. No, they're both mountain sites. In that regard, they're fairly similar. I'd say Springfield is possibly a less intimidating to start off with. Omarama, you're sort of straight away in amongst the mountains. Springfield, I'll pull up a photo. Springfield is in the we're actually on the flats. So I showed this the other day, but Springfield is in amongst the flats. So you've got nice fields. It's very safe. You can sort of land anywhere you want. Or I'm sharing a photo of Springfield, aren't I, Tim?
Yep.
Yeah, good, cool. Yeah, so Springfield's in amongst the flats on the Canterbury Plains, so it's very safe to fly. There's lots of places to land out, and you can slowly step your way in, going from the foothills, little hills, to then jumping into the bigger mountains. So I'd say in that regard, it's a little bit different. The other complexity that we have at Springfield that you don't tend to get at Omarama is we get the sea breeze coming a lot earlier because, like I said, because we're on the plains, we're quite close to the sea, so that does make trying to get away from the airfield can be a bit difficult, where the guys in Omarama tend to find it a bit easier on those days. So yeah, different but similar is my answer to that one.
Another question when the South Island goes into level 2, will there be anyone around in Omarama for towing and things? I'm assuming you're talking about. Probably.
I'm not the person to answer that. Is Dan McCormick or anyone on here?
Otherwise,
Yeah.
maybe get in touch with Milan. He'll know what the story is, whether he's doing any flights and whether towing's available. Cool. Any more questions?
Guys, I'm only a absolute newbie, but I'm aware there's a week planned at the end of September in Omarama. So that's again level 2 permitting.
Yeah, I personally don't know too much about that. I know they're planning a cross-country course, November, December, I think, before the regionals. So I've seen a bit of communication about it. So I know they're planning something, and like a cross-country course in the Marram is always great fun. So if you can get down there, I'd just say go for it.
Cool. All right. Well, if there's no further questions, we'll wrap up here. This will be going online for anyone who wants to watch it later. And we do have another talk in the plans, probably for next weekend. We're thinking of doing one with some of the Matamata guys, so stay tuned.
Just a quick comment. I tried to put a chat on there in response to Russell's question. Springfield's got a lot closer to airspace boundaries. Omarama is a lot less restricted in that respect.
Yeah, I'd say not. It does, but it's nothing we can't work around. And I wouldn't say we're generally heading west out of the low airspace. You're allowed to 7,500 feet above the airfield. I think there's a 5.5 line not far away, but we're always flying to the west of that. And then we step up into the 9.5 zone. So I'd say it's not very restrictive. But anyway, thanks for listening. I hope I've been some help. I found it's quite useful drawing on photos to try to explain your thinking behind it. So yeah, hope that been useful for at least someone.
It's really good. Thank you, Alex.
Thank you.